All right. So today, in the next 20 minutes or so, I'll be talking about Ethereum's intent machine and intents for Ethereum very fundamentally. It is sort of going through where we came from, why intents are cool, how intents actually matter for a lot of the practical use cases that we want to achieve going forward, such as privacy, for example, and how you as developers can leverage intents on Ethereum. Let's start with a very brief sort of background to come to why intents are cool and how intents actually work. So fundamentally, when we think about what a VM or virtual machine is, it's an instruction set, some program counter, has different layers of memory, and fundamentally runs programs sequentially, right? Sort of the best known example of a VM in our space is Ethereum virtual machine, which does exactly this. And really, all the things we've had so far are fundamentally virtual machines. This is, again, we had the Ethereum virtual machine being the first one, then we started innovating a little bit and started having other virtual machines, such as the Solana virtual machine or the Near virtual machine, or any of the ZK VMs, really fundamentally, right? Like any ZK VM, it's just a zero-knowledge virtual machine, but it's sort of the fundamental model here around running programs sequentially. And updating some underlying database state whenever you run a program, right? So if you have some database state A, and then you apply a transaction, and then you get to a database state B. Yeah, the best example that we all use every day is the Ethereum virtual machine, and this is also true for all the rollups, right? Like Optimism, whether it's Optimism or Arbitrum, all of these things are running the Ethereum virtual machine. In contrast to this, what is an IAM? So an IAM is something very different. It is also not a replacement to a virtual machine, right? Like intent machines or IAMs fundamentally run on top of virtual machines. They're not a replacement, they're like not yet another iteration of like, this is yet another virtual machine. They are fundamentally something that you can build and run on top of existing virtual machines such as the EVM. So an IAM takes a batch of intents, computes possible valid state transitions, selects one according to some criterion, and then updates the system state using the batch. They don't really exist in practice at the moment. There is no generalized intent machine in the world at the moment. The first one that is fully generalized is the normal resource machine, or ARM. And we'll talk a little bit about sort of what this enables you later on. But this is sort of just as a very brief background. On the technicalities on sort of we are currently living in this VM-centric world. And in order to give developers high levels of abstraction, similar to how we moved from sort of limited scripting capabilities in Bitcoin to a fully implemented virtual machine on Ethereum, we'll have to start moving towards an intent machine going forward. With this said, let's quickly go through that ANOMA is an interface. It is not an intermediary. And I will talk about a little bit why this distinction really matters. But the TLDR is there's no ANOMA chain that you must interact with. ANOMA is just code. It's a protocol specification. If you want to use intents on Ethereum, ANOMA is the easiest way to do this. So let's quickly go through what are intermediaries and what's the difference to interfaces, actually. So intermediaries are fundamentally actors on a network, right? Sometimes they're valuable ones, but in almost all cases, they are in a privileged position that allows them to extract rent, introduce additional security assumptions, or add unnecessary complexity or latency. And really, when you think of an intermediary, you always think of it as it's a specifically identifiable third party. This could be a single party, right, a single key that you're interacting with, or a multi-sig, but it could also be an actual decentralized system. A chain is an intermediary. It's a specifically identifiable third party that you're interacting with. It is not just an interface. So a really good example in our ecosystem is actually many bridges are currently fundamentally intermediaries. They are specific entities that you as a user must consider, or as a developer must consider in your trust model, in your usability model, right? Like, and this actually, interesting enough here, it doesn't matter whether it's a 1/1 multi-sig bridge, or 3/7 multi-sig bridge, or a chain bridge. These are all specific intermediaries that influence and affect your security model. In the real world, we actually have a really good example here, which is banks. Banks are sort of the prototypical intermediary. In order to access the banking system or the financial global settlement layer, you must interact with a bank. It is not possible for you to directly interact with a global financial settlement layer. You must always go via a bank, which to me, sort of on a technical level, is incredibly strange. I know there are like historic reasons for why we're going via banks, but sort of when you fundamentally think about the problem, I should be capable of just writing to this global financial settlement layer without having to go via a bank, because that bank now influences my trust model, right? Like, I now have to fundamentally pick the intermediary bank that I like, that I trust, that I believe in, because I can't just interact with the system directly using an interface. Interfaces, on the other hand, it's effectively a protocol which translates or represents one semantics of ordering, compute, and storage of an underlying machine. They're simply code. You can freely copy them, you can re-implement them in your favorite language, you can use them everywhere. If two people in this room just want to agree on using the same interface, they can, right? Like, there's no routing point that they must go via. In the real world, my most favorite example here is TCP/IP. TCP/IP would have never worked if it was designed as an intermediary rather than an interface, right? Like, two of us in this room can just decide that we would like to connect to each other using TCP/IP. There's no server somewhere running in Virginia that we must route via. TCP/IP would have never gotten traction because A, it was always have affected the security model, and B, it would have affected latency, right? Like, because we would have had to route via some third party. And yeah, just to reiterate here, really, the ANOMA protocol, it's an interface for declarative intents, imperative ordering, compute, and storage semantics of underlying machines, such as the EVM on Ethereum mainnet or on Arbitrum or Optimism. It is an intent machine. It's an interface that you sort of agree to use. Yeah, I said this in the beginning. There's no ANOMA chain to which you must send your intents. This is a model that would never work, even though a lot of people are currently trying to propose this. Send your intents to my magic system in order to get things done. Whenever you use things in the blockchain world, really think of this, think about this. Whether are you using an interface or are you using an intermediary? And you should always try to prefer to use actual interfaces instead of intermediaries, because it really matters on the usability, on the latency, on the security of the underlying system. So, with that being said, ANOMA is fundamentally a universal intent machine for Ethereum. There we go. So what does this specifically mean? Well, it means that builders can write dApps in terms of intents instead of transactions or execution traces. And really, when you think of a transaction is sort of this like very imperative description of the compute to execute. Whereas an intent is this very declarative model on, I currently have state A and I'd like to be at state B, and I don't actually care how the compute happens. Just like make it happen. And the really nice thing is you get incredible levels of composability here, because you only have to be composable at the state layout rather than at the execution trace layout. Let me also quickly catch up here. There. Great. Really, an interesting note here is that intents are mostly already around us. We just don't yet have a good sort of generalized abstraction for them. And sort of the biggest intent-centric system that no one really thinks about is a rollup. Like, when you think of what a rollup is some user has an intent from A to B, someone else has B to C, someone else has C to D, and then a rollup provider just comes along and collapses that entire compute, that chain of compute, into one settable proof somewhere else, right? Like, their signature sort of like closes the loop from D to A, and now you have an updatable system. Because individual transactions in a rollup should actually be called intents, because they're not directly settable on the underlying system. They are these partial state transitions that represent partial compute, rather than fully fledged state transitions that are directly settleable. Yeah, the other thing that means is, with ANOMA you get a universal standard for intent and application formats, which does not constrain what kind of intents can be expressed. And I think this is actually a very important thing, because people tend to ask me like, well, aren't all intents just limit orders? And it's like, no, that's really clearly not true. All limit orders are intents, but not all intents are limit orders, right? Like, intents are fully generalized, whatever you can express. Whether this is you want to be part of a multisig, as in like I have a third of a gnosis safe multisig, that's my intent to combine my partial signature with someone else. Whether I want to trade A for B, intents are fundamentally just partial state transitions. And here, ANOMA as an infrastructure or as an interface does not constrain what kind of intents you can express. It just, whatever you can write in code can be an intent. And maybe the most important thing here is intents and dApps written with ANOMA can be ordered, solved, and settled on Ethereum or anywhere in the ecosystem. And I don't really have enough time to go through this here, but to a large extent, ANOMA, as using Typhon as a consensus mechanism, which if you're really interested in distributed systems, check out Typhon chimera chains. It generalizes shared sequencing. So it generalizes the problem of shared sequencing. How do we defragment liquidity across many of our rollups in the ecosystem? Yeah, so ANOMA is a universal intent machine for Ethereum. Intents and dApps written with ANOMA can be ordered, solved, and settled on Ethereum or anywhere in the ecosystem. This could be on an EVM rollup. This could eventually, once someone builds an implementation of ANOMA of sort of the operating system abstraction for the next ZKVM. This can be on the next ZKVM rollup. This can be on eigenlayer AVS. Really, the easiest way to think of this as an operating system abstraction where ANOMA is a distributed operating system that allows users to write and use applications against the operating system abstraction, and you just have to implement the operating system, for example, to run on the EVM, to run on a rollup, to run on a ZKVM. Yes, so with that, let's go through some of the affordances of what ANOMA actually gives you here. And I think there are 4 key affordances, which is it's permissionless infrastructure. There's no specific intermediary that you must interact with. Ethereum validators can choose to run ANOMA sidecars to connect the entire P2P gossip stack to each other. The more nodes in the ecosystem exist, for example, to run along some of the major rollup sequences, this is just a permissionless infrastructure where you decide under what conditions are you willing to connect to other people on the network. This is not that you must all agree on some form of global state updates. And sort of the key thing here is that ANOMA was designed to be incredibly topology agnostic. Topology is not actually something that you can define in a specific architecture diagram. Topology is like the topology of the network is specifically dependent on user behavior at runtime, on the specific economics that emerge at runtime, on like who wants to be connected to whom. And then you get intent level composability. So intent level composability has 2 parts. It has the intent level composability, as in, as a user, I don't have to specifically say, well, I would like to go to application A or application B to do my trade. I can just say, well, I'd like to sort of update this state, and then maybe this gets executed on Uniswap, maybe this gets executed on CowSwap. As a user, you don't have to care anymore. You can just say, well, I would like to get A for B, wherever is cheapest, fastest, you can sort of set your preferences. And the second component is you get intent machine composability, which is, I think, actually the single biggest unlock which enables shared sequencing. It's the ability as a developer to treat a network of intent machines as a single intent machine. So that means that rather than as a user or as a developer saying, well, I would like to deploy my application to Optimism versus Ethereum main chain, you just deploy your application against the intent machine, and then users make the choice on do they want to run your application on Optimism, do they want to run it on Arbitrum, do they want to run it on the main chain, right? Like this is sort of like, it becomes a user-defined behavior where your application actually starts running, and it's possible everywhere where the operating system exists. And I think this is going to be sort of an order of magnitude higher levels of composability, because all of a sudden as a user I can say, well, I would like to trade A for B. I don't care against which specific application it gets executed, and I don't actually even care whether it gets executed against Ethereum or whether it gets settled on Ethereum or Optimism. Just like giving whatever is the fastest or cheapest, right? Like, and this is sort of the level of unlock where instead of users having to manually pick specific RPC endpoints to go to, they can go and describe this in their intent, and then solvers figure out the rest. The next part is information flow control. And information flow control is a different word to say privacy guarantees. This means that from both a scalability as well as sort of a usability perspective, a lot of the state that is currently in the center of the network, right? Like when you think of Ethereum, there's a lot of global state in the middle. A lot of this state is moving to the edge devices. Like any ZK rollup, for example, needs this kind of intent-centric design because data or state moves to edge devices. And so information flow control is all about how do users have the capability to decide what parts of their state are they willing to reveal and under what conditions. So for example, maybe if I want to trade transparently, I attach a plain text signature, and if I want to trade privately, I attach a zero knowledge proof, right? But this is not an application definition. This is not like you as a developer, you have to write a specific circuit to make your application implement information flow control. It is now a user choice on how are they willing to reveal state updates about their local state on their local device. And the last bit, scalability here really matters. The most scalable system is the system in which data lives at the edges of the network rather than in the center, because if it lives in the center, we need to come to global consensus over that specific piece of data, and everyone needs to sort of sync it and so on. And the last bit is heterogeneous trust. And this is really about the idea that not everyone will want the same security model, right? Like my parents will never want global Ethereum. And like there's nothing I can do in the world to change that fact. They do not understand how the system works. They won't trust it. They will want like their local government security. And that's fine, right? We should just be building designs and architecture so that our applications can roam between these many different heterogeneous trust models so that we aren't splitting the liquidity, that we aren't fragmenting the liquidity and state between many different systems. The other example here is like some users want to trust their rollup. Like some users want to go into, so I would always want to be on Arbitrum. I always want to be on Optimism. And this is what this enables, that we can have a uniform application interface that can work across many heterogeneous trust models. And maybe the last bit here is actually, I think it's kind of crazy to assume that any central government will ever issue this digital, like their currency on Ethereum. Like this will never happen, no matter how much we wish it would happen. They will never give up the monetary sovereignty to any decentralized system. So I think the best we can hope for is that we build architectures that allow this heterogeneous trust so that on Ethereum main chain, we can leverage that liquidity that exists now on sort of the Swiss franc chain where the Swiss government issues its own currency. The last bit I'd like to talk about some novel dApps that you can build here using ANOMA on Ethereum. And these are not the typical financial use cases because I really hope that over time we actually build non-financial use cases in this industry. So Public Signal, this is I think one of my top favorites. Public Signal is an inverted version of Kickstarter where rather than people providing supply and going, well, I'm willing to do this, you can have a model where we all signal demand for a certain action, and then only if there's enough intents with that signal, enough demand, can you take all these intents together, provide the supply, and then settle this on chain. So one example here is like we all like to get a cup of Starbucks coffee. Maybe if we get 100 people together, there's now enough demand that's being signaled, and then someone can sort of like fill the last bit, the last intent, which is I will provide 100 cups of Starbucks coffee to this venue under these conditions, and then you can actually settle this. This is my favorite. It's scale-free money. I think this is actually the end game for this entire space. It's everyone issues their own local currencies that represent your own economic trust graph and your own economic relationships with the rest of the ecosystem. And scale-free money just allows you to leverage intents to have these incredibly flexible systems where my intent can purchase someone else's local currency, can purchase someone else's local currency, so that we get this connected economic system that actually represents much better the fundamental economic realities that exist rather than sort of abstracting it away by using money. Multi-chat, it's an effectively encrypted version of Slack. And then the promise graph, this is all about how can you structure organizations around the actual work being done rather than sort of some imaginary hierarchy that you think is the right organization abstraction. Yes, I will give you 25 seconds or so to actually scan this. If you want to chat about more application ideas using intents, feel free to scan the QR code. There's been a bunch of activity there. And yes, I didn't really speak here about novel things that can exist within the financial realm, but intents are also just the better abstraction for things like order book exchanges. Like if you actually want to have a decentralized order book exchange, you need an intent-centric design. Yeah, quick TLDR, it is virtual machines and intent machines. It is not versus. Intent machines do not replace virtual machines. Without the Ethereum virtual machine, the ANOMA resource machine has nowhere to run. This is sort of like, virtual machines are fundamentally our settlement components. Intent machines are just a higher level of abstraction to make developers and application users' lives easier. Really think about interfaces, not intermediaries. I think if we all start becoming too reliant on the intermediaries, we've kind of failed at what the space was supposed to achieve, which is actual decentralization and censorship resistance. Every time you use an intermediary, your trust model just looks a lot more like Web 2. What does universal intent machine mean for Ethereum? Well, it gives you intent-centric dApps and fully generalized intent-centric dApps. It gives you a standard for intents and gives you the ability to settle on Ethereum or the wider ecosystem. We spoke a little bit about the affordances that ANOMA gives you here around permissionless infrastructure, intent level, as well as intent machine composability, the ability for the first time to have incredibly flexible generalized information flow control, and the ability to have heterogeneous trust models. And yeah, then we spoke about some novel ideas for dApps on Ethereum. Again, if you would like to this is a very brief, sort of 20-minute, brief introduction, right? If you'd actually like to learn more about how a normal on Ethereum looks like and how it works and a lot of the underlying research around generalized sequencing, scan this QR code. It's a very cool post that my co-founder wrote on ETH Research. It is dense. It will take you probably 2 hours to read easily. Yeah, I'll leave this up for another 10 seconds or so. All right. With that, thank you very much. This was Ethereum's Intent Machine, and I hope you enjoy your day.